Hello, my fellow YouTubers. This is Roy back again. You got to be asking yourself, what does that have to do with this? Well, when I started creating this mechanical version, I started to think how I can create one that's in a coil form. Dual primaries. All right. Let's start off real quick. I'll go through this and you guys can be on your way. So we'll start off with A, B, and C. A is the primary. The top one here it's a bifilar, and you can see that the start of the primary is right there. So it turns counterclockwise, and so does the coil in the center. Turns the same way as this coil. It's the primary. Now, underneath the primary and sandwiched in between these two conductors is a dielectric, and here we have a pickup. And this pickup is wound clockwise. So it starts right there, and it's wound the opposite way as the top section, and the opposite way as that coil there. And this clockwise is the wind that's on this coil down bottom. Now, the interesting thing with this is I'm going to set the primary up to start off with my 15,000 volt, 60 milliamp beer bottle capacitance, and we're going to fire up this primary and treat it like a agitation cycle on the washing machine. So it'll be swapping where that start connection is positive on a half cycle and negative on the other half cycle. And we'll have a contact out here when we find the resonance. When we start to tune this thing, we'll find resonance in one of these turns out here. You can see there's 1, 2, 3, 4, 5, 6, 7, 8 turns. This here is our pickup coil, and that will release the capacitors that will be discharged. And something unique I just figured out, let me see if I can get this on the ground, one hand, is the inside. See if I could get a good view. So the cone of the coil down bottom protrudes into this coil, and vice versa. This coil protrudes into that coil, about that much into the coil. So I can't say a third, but a good portion, a good eighth. You can see that the rod here is the elevation, so I would almost say it is a third to that rod. There's a rod on both sides. The crazy little phenomenon that I realized already is I was trying to dry out some of the polyurethane that I have on here, and I stuck a fan on it, and when I did, this is what I noticed. Now I want you to, this fan's on high, okay? Now watch what happens when I stick the fan. Listen to the fan. The fan slowed down. The fan slowed down. Let's pick it up. You hear it's on high, moving fast. I lower it down on this. it slowed down. Kind of reminds me of the conductor, the aluminum conductor I put around the magnets, where the wheel slowed down to nothing. It didn't. It's not stopping this, but it slowed it down. Here, pick up speed right there. So that's an interesting thing, but it kind of stands to reason why it would happen, because of the magnetic field in that fan motor is being choked down by the conductor of copper. The same lens effect just showed up. Mr. Lens just showed up in our face. And that's the unique thing about this. So what am I expecting to happen when I go to hit this? I'm not trying to make a Tesla coil, but this is a unique array. And I would say it's leaning towards the free energy device, and how it would create free energy. It would tap into the ethereal energy on the backswing, just like a transformer power lines do when they're in between their cycles. They trap in ambient radical electrons and rarefied air, and that's what we're looking here, because this cone being wound clockwise, so there's a clock rotation. This cone comes up and clockwise up to about this high here, or about this high, and then you got that rod with the wire coming up, and that wire needs to go to something, and I believe that wire is going to go into a capacitance. Now, whether or not I use a toroid and use the toroid, but that to me seems a little Tesla-ish. If I had one on the top and one on the bottom, but there's multiple experiments I need to do here, and I'm not looking for energy to blow out like the Tesla. So it would be, I would think it'd be more on capacitors that are like, let me see what I have in the goodie box back here. It's got some weight. So maybe something like this. I call these little cherry, they're capacitors that are 20,000 kV. Let me see. It's upside down. Should be 21,000 kV, and that's 1,500. Be nice if I can focus in there. 1.5 nanofarads of capacitance. So I built 2 capacitor banks. I have that capacitance release. Now, what's going to happen on this equatorial plane, I'm going to call this, it would be, primary would be A, and then you would have pickup would be A plus, and then A prime, we'll call it, and then you would have B would be your pickup here, and then there's going to be about 300 turns of some 26 gauge wire that's going to be right here, and that's going to be the start of the secondary, which will be these coils here will be secondary coils, and that would be A prime, B, and then B is going to have B prime right there, and then there's going to be C, and C is B prime is the secondary pickup, and then at C and then C prime will be the secondary itself. Now the secondary itself, it's taking the positive end and running through each other. So it's going to be the high side about right here, and then it'll be the high side from this cone about right here. So there's going to be a difference in potential will be spread out in the middle. So there's the potential difference between this bottom point and this top point will be because I put a resistor on one of these coils. They're both about one's 5.9 ohms, and the other one I have 6.9 ohms. So I got 1 ohm difference between the coils. So with both of them being hit the same time, there's going to be a difference in potential between the top of this point and the bottom of this point. And we're going to call that a diamond, because you're going to have a top end of the diamond here and a bottom end of the diamond. And then you're going to have your dielectric, which is shooting out through the sides. Now we're going to break out with the oscilloscope. I got to put a couple more coats on here. I want this to be about a good 1/8 of an inch thick in poly. It's really insulated good. And we're going to do an experiment with the oscilloscope, and we're going to look at the wave. And we're going to focus on the wave that is being produced, which we're going to have to use my variac off the wall into the NST, and we're going to have to go down in volts to get it first 100 volts, then 200 volts, 300 volts, and start looking at the wave, and then go up in volts and see what characteristics change. And then from there, we're going to focus on the wavefront. And when I say wavefront, is how much are we going to charge up the capacitor banks? There's going to be 2 banks, right? So the capacitor bank is 1, the current, 2, the wavefront. So if you look at a circle, it's 360 degrees. And obviously you have to have a reference point of where the circle starts. So if you look at the start of the wire, say on the primary here, that would really be the 12 o'clock position. So one end starts 1 o'clock and it goes around. That so that would start the position of the 360. So we would have a time frame from say from 0 all the way around to 360, whether it's 180 or whatever you use on there. In reference in time to get there, that's going to be the charging time of the contacts of the assembly circuit that would ultimately charge the capacitor and release the capacitor. And the capacitor released will look at the capacitors being like Eli the Iceman, where the current is leading the voltage coming out of the capacitor, and the wavefront, the angle of that wave is going to be what we're going to be matching on the angle of the cone. So this is like a 22.5 degree angle. Now once we match that capacitance wave front on the oscilloscope to the wavefront of the cone, we'll start to see some formulation of resonance built up in the humps of the sine wave that we're creating from the NST. A lot more to get into, guys. I sort of get myself a little lost without without just not having it written down, which I will do. And I just want to say the fact that to build something mechanical from a vision and to understand these magnets are more like little coils, and these coils you charge up and they become strong magnets, and you can't look at them as just magnets, or you can get caught up in getting lost in what is it really going to do. This array here will bounce into and we'll work off the electrostatics in the center, and we'll talk about referencing how what I'm building here in a rough mock-up to what I'm building here as a fine-tuned transformer that will create a space from the top of the cone and the aura on top of the cone to the bottom of the cone on this one to the aura of the cone is the electromagnetic field, is the aura I'm calling it, and then the expansion. So we'll be able to see the wavefront change on the oscilloscope as I expand the 22 degrees that we have here in a, we'll call this, in a computer sense, you have your software and your hardware. So this here is the hardware, and then the software, we're going to apply and tune it, and then we're going to vary the degrees. So the 22.5 degrees start can also be altered to go outward, just like it is on the one chart that I'll bring a couple charts out from Walter Russell, and this is just my version of what Walter Russell and James Clerk Maxwell, my ether friend, the spirits of himself, James Clerk Maxwell, and Walter Russell, and Benjamin Franklin, and Mr. Tesla. They keep showing up in my workshop and keep introducing themselves to me, and out of nowhere I'm into this. Leave your comments. Hello, my fellow YouTubers. This is Roy back again. That's a sign of a happy dog. Look at him smiling. He's a horse. Suntan in the coil. Nah, I just put some polyurethane on it. Added 2 other coils. These are going to be my RF choke coils. It's going to be a solid DC. Sort of like a saturable reactor, where we're going to limit the current going through the AC, which will be the 2 cones. And the best thing, of all best things, is we're going to draw a schematic up on this puppy. So you can see here is the, called the equatorial plane, the dielectric. Here's my 2 DC coils. Here's the penetration of the cones into each other. I'm going to start filling this out, and we'll have something all you guys can run off of. Leave your comments. Peace out. Hello, my fellow YouTubers. This is Roy back again. Let's take a peek. Spin in opposite directions. Conical. Choke coil. Dielectric. Choke coil. DC. Conical. Inside the conical is the cone shape I don't know if you can see that. I don't feel like moving it. Oh, I guess I could. Got the conical on the inside the cone on both sides. Peace at least gallon. Peace Tesla. Let's get down to it. Looks like I'm a drawing table set up here. Given to me. My daughter didn't want it anymore. It's her drawing table. We're gonna just do a couple minutes, a few minutes of talking, and we're gonna get into why this is being built by me, created by nature, and pushed for me to build, and the process through all my fellow YouTubers. Yes, you guys are going to be let in on the secret, and you guys already gave me a lot of information, and we're going to push through it. So let's start off with some of my notes here. This is just basic to start the process for you to understand why this is being built. We'll get into some stuff that's not on here. This is just the start page of this process, okay? There we go. So just screenshot that so you can come back and read it. Okay, bam. And we're referencing why this is being built, okay? So we're calling this project here a quarter wave resonator, okay? And why I call it a quarter wave resonator is why we're going to have this 2-minute video, okay? So a quarter wave resonator is a secondary coil. Wire must be a quarter wavelength of the resonant frequency. So whatever frequency you're running there, a quarter wave resonator. What does a quarter wave mean? Let's just go a little deeper. Quarter wave resonator is a tube closed at one end and open at the other. The walls and rigid ends of the tube confines the body of air within the resonator cavity. Under certain conditions, this body of air can be brought to a state of resonance. Brings us into the next part, octaves, okay? So this is what I'm feeling from nature and when I'm pulling in. It's music related. It's music related, but it's also my electrical experience from what I learned the last 7 years into the equation. So what an octave, let's go what an octave is now. So octave is a perfect octave is a interval between one musical pitch and another, which double its frequency. So we can increase frequency by having an octave. Now, what is this all about? The main question, why am I building this? I didn't know in the beginning, but this is just getting into Walter Russell and not so much Walter Russell, but having the experience between Tesla and other greats that pull all this in. I'm talking Maxwell. I'm talking Benjamin Franklin. Out of the outside of the envelope, from like Steinmetz or you definitely got Tesla. You got Einstein. You got man. I just like ramble myself off of all the greats. I'm going to make a list of the greats, and I won't ever forget the greats. But the troubadours, the greats, the ones that I'm stupidly forgetting about right now. Woo! Let me take a deep breath. So anyway, let's get into this. Schumann resonance is why we're building the quarter octave wave, okay? Resonator. The tube, the resonator. There goes your resonator, guys. This is going to be like Earth's heart. This is going to be the heart pump that all humanity is going to have to be able to pull workable energy off of, and very little in and everything you want out, okay? Because we're pulling it. We're not getting free. It's not free because there is no such thing as free. Energy is never, energy don't dissipate or die. It gets transferred. So basically, it's just we're pulling from a different place, all right? So instead of using electromagnetic and iron, which iron and electromagnetic, beautiful, beautiful, beautiful. But from when trying to get above the usage that you have created, that mankind is used to at this day, meaning like today we have blenders, we have washing machines, we have pumps, we have you name it in our household as far as usage, different lights, everything different, yada yada, all kinds of usage. So basically at that point, if you were a mathematician, you would just calculate all that and it'd be a number, and that number is now greater now than it was in 1900 or 1860. Okay, so you start getting into Faraday, you start getting into Leifweight, you start getting into different people, Maxwell, you start bringing in stuff, but you got to think about those people were coming to light only because their research of people before them, the troubadours before them, and I'm talking about like way back when you're talking about Faraday, you're talking about yeah, there's another brain fart. Let's go to the Schumann. So, in sound-wise, if you take the Schumann, and sound has a lot to do with this, because you get into octaves, you're dealing with sound, you're dealing with electric. It's kind of coinciding, but there's a little differences in a sense. Schumann, when converted into sound waves, 7.83 is a flat. That's a B2. 2 octaves below the lowest note on the piano. 2 octaves below the lowest note. That's a big deal, guys. The electric powers hum at 60 hertz here in the USA. And it's the 9th overtone of the earth. And the loudest note from space is a B1 to a B, deep B, solid deep B. Think about that. Give a shout out to my boy Angel out there. Woo! With the posse. Give a shout out to my boy AAA Clay. Also, Scott Russell, made by one man. My boy Bill. Gotta give a shout out to my boy Bill. Damn, Bill. Bill. He's been really helpful, actually. I think the name of the channel he has is Renew It. note, or damn, I know I screwed that one up. Sorry, Bill. Terry Woodhoff. Terry. Tesla. I can't give a shout out to my boy who's no longer on YouTube, which is Abraham's Lab. Brian. Damn. I just feel like he's my brother. Just haven't met him. All right. And Deeds. My troubadour with the damn Slayer over there. Deeds. I put Deeds out there. I got to give a shout out to Tesla Explorer. He's the real troubadour on taking different Tesla systems and perfecting each one like a scientist. Like a scientist, you never, ever, ever, like, couldn't even distract the guy. That's, to me, love to talk to him because he reminds me of that. And so does Terry. Terry's that mad scientist. If you watch Terry Woodruff's channel, geez, Terry, man, I want to hang out with you for at least a week. Locked in. They could throw peanut butter and jelly and bologna sandwiches with a lot of mustard in there. As long as I have water, we're good. Maybe a couple other things, but I ain't going to mention those online. Anyway, back to this. The dielectric really does come into play because the dielectric, this plastic here, you have a place where the energy is stored. And the energy that would be stored in here would be the energy that comes in from, I'm going to call it from behind the screen or behind the sheets. It's sort of, it's counter space. Counter space. Why do I even say that, counter space? Well, there'll be a 1/4 inch tubing and a 16-inch gauge wire, 20 feet on each end, that becomes a bifilar, and one is created as a primary, which is the power in, and the other side is identical, but it's spun the opposite way. So pretty unique situation how we're driving this, and not tonight, but another night we're going to get into the next. We'll have another 3 pages of what we went over tonight and some more other stuff that we have to add here. But just remember, this is AC here moving, okay? The whole thing is to keep the energy moving. Here's your AC. Here's your DC. Where the DC in play here wound the opposite direction. So this is wound one direction, this is wound the same direction, okay? And then over here, if this is wound the opposite direction, this is wound the opposite direction. What happens here is we create a compressed space here in this dielectric. We're going to have a magnetic field that's going to be very forceful right here in the center here. On top of that, on top of this dielectric here is going to be 2 1/4 inch conductors with a 16-inch gauge wire bifilar, okay? And one of them being a push that's coming in as the power source in, and the one at the bottom here is the power source out. Power source out coming out is not only related to the back EMF from the power source going into the dielectric, but the dielectric is getting its push. Its push out from the other side of the dielectric will come into this conductor here, and this conductor here would be the pickup, along with the 16 gauge wire. But this is all done in compression in the center of these cones, because one cone, is feeding it inward this way. The other cone is feeding in this way. At a point from having a RF choke, meaning a DC presence in the center of opposite poles here, will allow this become a springboard. Now, the springboard that I speak about here in the relations between the top cone and the bottom cone, even though they could be wound the same amount of turns with the same wire, you add resistance to one side. Now, if you add 1 ohm of resistance to one side versus the other side, you're going to have a difference in potential. Now, think about this. What's going to happen here in this oscillation is this peak of the cone and this peak of the cone are going to be high and low pressures. But these high and low pressures are going to do this. They're going to swap like a damn wash machine going side, like horizontally. Meanwhile, the top cone and the bottom cone are swapping like a washing machine going the opposite way. So you're going to have a torque that's going to be created from the top and bottom, and then you're going to have a difference in torque between this point and this point, because you're going to have a counter. It's going to be, if this is one high pressure, this has got to be the low pressure. If this is the high pressure, this has got to be the low pressure. So what you would have is, at one half cycle, you have a low, high, low, high. And this would be just varying up and down. And that's varying is going to be a quarter wavelength of the Schumann resonance. And with the tapping into the Schumann resonance with this resonator, it will provide an ample amount of resources in the center here. I don't even know where it's taking me to the next level, but I'm just going to leave it right here. You guys got it. It's getting in writing. Peace out. Love you all. The wave resonator.